using the Heaviside function, we can now describe functions with f jumps. And in particular, let's find the Laplace transform of f, where f is the following monster. And in this case, let's first illustrate this with a picture. This is maybe the t-axis, time, and then the values. So this function, it first starts at 2. Maybe here the value 2 until 4. And then at 4, it jumps up to 5. 5 until 7. At which point it goes down to -1. So even below the t-axis, this is -1, and that is at 7. And then at 9, it jumps up to 1. Maybe like this. And then it goes up to the value 1. And it just stays at 1. So this is what f of t looks like. And in order to find the Laplace transform of f, the first thing is to write f in terms of our Heaviside functions. Because remember, Heaviside function means jump. So write f in terms of jump. And we can do this in the following way. So step 1. Write f in terms of UC. Write f in terms of UC. And we do it as follows. So we start with the initial value. Start with 2. This value. And then all you have to do, you have to figure out where you jump and by how much. So the first jump happens at 4. And the jump is by 3 units. So essentially, you jump by 3u4. So at t equals 4, jump by 3. And you will see that we have to add 3u4 of t. And that's because u4 means jump at 4. The 3 means how many units you jump by. And then you continue. So the next jump is at 7. And you go from 5 to -1. So you jump by -6 units. So -6u7. And last but not least, at 9, you jump from -1 to 1. So you jump by 2 units. So 2u9. So at t equals 7, jump by -6. And that gives you a -6u70. And finally, at t equals 9, you jump by 2, and that gives you plus 2u9 of t. So what is our function? So f of t, once again, you start at 2, then at 4, you jump by 3 units. At 7, you jump by -6 units. And at 9, you jump by 2 units. So this is what your function is. And in fact, it makes sense if you use the definition of UC, because before 4, all the u's are 0. So f is just 2 plus 0 plus 0 plus 0, which is 2. After 4, but before 7, u4 is 1. Everything else is 0. So f is 2 plus 3, which is 5. And then 2 plus 3 minus 6, which is -1. And then 2 plus 3 minus 6 plus 2, which is 1 in the end. It's one thing. And then, of course, the next step is to take Laplace transforms. And I would like to remind you of the Laplace transform of the Heaviside function. It was exponential, so e of minus cs over a hyperbola. So now the Laplace of f becomes the Laplace of 2 plus 3 Laplace of u4 minus 6 Laplace of u7 plus 2 Laplace of u9 and then it just falls like bread and butter because Laplace of 2, that is 2 over s, plus 3 e of minus 4s over s, you can see is 4 here, minus 6 e of minus 7s over s, and then plus 2 e of minus 9s over s. So as you can see, any function that has jumps, you can describe it with the UCs and you can take Laplace transforms of them.